In the frigid outer reaches of our solar system, a cosmic drama is unfolding, one that has captured the attention of the world's leading astrophysicists. Pluto, once our ninth planet and now relegated to dwarf planet status, may be on a collision course with the ice giant Neptune. At least, that's what some sensationalized headlines might have you believe. But what's the real story? Is this distant world, 4.67 billion miles from Earth at its closest, actually posing a threat to the delicate orbital balance of our solar system? And if so, what might happen in such a catastrophic encounter? Welcome to Waves Discovery, where today we're diving deep into one of astronomy's most misunderstood relationships, the orbital dance between Pluto and Neptune that's been ongoing for billions of years, and might be more precarious than we've been led to believe. Before we continue, take a moment to hit that subscribe button and ring the notification bell. Trust me, what you're about to learn will change how you see our solar system forever. When Clyde Tombaugh discovered Pluto in 1930 at the Lowell Observatory in Arizona, the astronomical community celebrated. After years of searching for the theoretical planet X that was supposedly perturbing Neptune's orbit, it seemed the mystery had been solved. Pluto was quickly designated our ninth planet, a status it would hold for 76 years. But Pluto was always an oddball. Unlike the other planets we knew, it didn't quite fit the mold. Its orbit is highly elliptical, more like a comet than a planet. It's tilted 17 degrees off the ecliptic plane where most planets orbit. It's incredibly small, smaller than our Moon, with only about 0.2% of Earth's mass. Its composition is primarily ice and rock, more similar to a comet nucleus than a terrestrial planet. These peculiarities were just the beginning. As our telescopes improved and our understanding of the outer solar system grew, astronomers began discovering more Pluto-like objects in the region beyond Neptune called the Kuiper Belt. One of these objects, Eris, discovered in 2005, appeared to be even more massive than Pluto. This discovery forced astronomers to make a difficult decision: either accept numerous new planets into our solar system or reconsider what qualifies as a planet in the first place. As many of you may remember, and some still passionately debate in my comments section, the International Astronomical Union made their infamous decision in 2006. They created a new classification system with three main categories. 1. Planets, Mercury through Neptune. 2. Dwarf planets, including Pluto, Ceres, Eris, Haumea, and Makemake. 3. Small solar system bodies, asteroids, comets, and smaller Kuiper Belt objects. For Pluto to be considered a planet, it needed to orbit the Sun, which it does have sufficient mass to be rounded by its own gravity, which it has cleared the neighborhood around its orbit, which it hasn't. It was this third criterion that demoted Pluto. Its orbit intersects with numerous other objects, including Neptune itself. And that intersection is precisely what brings us to today's mystery. Despite losing its planetary status, Pluto gained something perhaps more valuable in 2015, a close-up portrait. NASA's New Horizons spacecraft completed the first-ever flyby of this distant world, transforming it from a blurry dot into a complex, geologically active world with a massive heart-shaped region of nitrogen ice called Tombaugh Regio, mountains of water ice standing 11,000 feet tall, evidence of cryovolcanoes that erupt with liquid water and ammonia, a thin atmosphere of nitrogen, methane, and carbon monoxide that expands and contracts as Pluto approaches and recedes from the Sun. A surface covered in various ices, nitrogen, methane, and carbon monoxide. Possible subsurface liquid water oceans maintained by radioactive decay in Pluto's rocky core. These discoveries shocked the scientific community. How could such a small, distant world so far from the Sun's warmth maintain geological activity? The answer lies partly in Pluto's eccentric orbit, the very feature that brings it dangerously close to Neptune. If you were to model our solar system to scale, most planetary orbits would appear as nearly perfect circles around the Sun. Pluto, however, traces an elongated ellipse that's tilted relative to this flat plane. This means that while Pluto spends most of its 248-year orbit far beyond Neptune, for about 20 years of each cycle, it actually dips inside Neptune's orbit, coming closer to the Sun than the giant blue planet itself. Wait, let that sink in for a moment. A smaller body regularly crosses the orbit of a massive planet and somehow avoids collision. This would be like a motorcycle weaving across the lanes of a highway filled with semi-trucks without crashing. How is this possible? The answer lies in what astronomers call orbital resonance, a phenomenon that reveals the hidden mathematical harmony of our solar system. Pluto and Neptune engage in what's known as a 3-to-2 orbital resonance. For every 3 times Neptune orbits the Sun, taking about 495 years, Pluto completes exactly 2 orbits, taking about 498 years. This isn't coincidence, it's gravitational choreography at its finest. Kindly like, share and subscribe my channel for further more updates about space.